Alongside the Ryzen 9000 and 9000 X3D CPUs, MSI has launched a variety of new 800 series motherboards. Amongst them, we have the X870 Tomahawk Wi-Fi, a mid-range board that's primarily catering towards gamers. We'll be pairing the board up with a 9800 X3D along with some low-latency DDR5 memory and seeing if it's the right choice for your next X3D gaming build. At its $300 price point, does it justify your hard-earned money? Well, let's dig in and find out.
Hey, if you enjoy content like this, drop a like, make sure to subscribe, and smash that bell so you never miss another video.
Hey, what is going on guys? Danny here. Welcome back to the channel and I hope you've all been doing well. Today we'll be checking out MSI's X870 Tomahawk Wi-Fi motherboard, a new board that's part of their 800 series lineup to support AMD's Ryzen 7000 and 9000 series processors. It's been a while on the channel since we checked out AMD's platform and did some testing with it. I've done some builds in the past with some AM5 boards for others, but never really featured one on the channel. But I've been quite excited to check this board out because I'm in the midst of also testing out some games with this board paired along with AMD's latest 9800 X3D processor that so many tech tubers and PC hardware sites have labeled as the gaming CPU king. I'll be showing results with the CPU overclocked and memory tuned, and we'll be pitting it against my tuned 14900K and 285K. That video is coming soon, so stay tuned for that content. To kick things off, let's go over the unboxing experience. The box is minimalistic, just the logo for the motherboard on the front, and then when we turn the box around, we see some key features listed on the back pertaining to power delivery, I/O, expansion, and more. Inside, we get the essentials: a Wi-Fi antenna, 2 SATA cables, an M.2 standoff kit, RGB extension cables, a USB driver stick, and the usual manuals and quick start guides. The board itself comes securely wrapped in an anti-static bag, though as always I'd appreciate a foam insert for added protection during shipping. The MSI MAG X870 Tomahawk has a clean, no-frills design that ditches flashy RGB for a more understated and industrial look. The board features subtle green accents on the heatsinks and branding, which give it a distinct but minimalistic style without overwhelming your build. The dark grayish PCB complements this design perfectly, offering a stealthy base that pairs well with almost any hardware configuration. The matte finish on the heatsinks and the subtle etched patterns add a touch of class as well. The overall look is purposeful and solid, aligning well with its Arsenal gaming branding, rugged, reliable, and, well, ready for business. Whether you're aiming for a military-inspired build or just prefer a clean, cohesive theme, the X870 Tomahawk delivers a premium yet restrained visual appeal. When it comes to power delivery, MSI has incorporated a good, robust setup that will be adequate and ample for the vast majority of gamers. Even if you will be overclocking with high-end CPUs like a 9800 X3D or 9950 X3D, the X870 Tomahawk uses a 14+2+1 digital power delivery system. MSI uses the MP2857 PWM controller paired with MP87670 power stages rated for 80 amps. This combination delivers clean and efficient power to the CPU, and while it's not as overkill as some of the flagship boards, this VRM design is more than capable for enthusiasts and overclockers alike. Cooling is a key highlight of the X870 Tomahawk Wi-Fi, and MSI has clearly put the effort into ensuring this board handles heavy workloads without really breaking a sweat. The VRMs are topped with an extended heatsink design that stretches across the power delivery area, maximizing surface area for better heat dissipation. What's particularly impressive is the inclusion of high-quality 7 watt per meter Kelvin thermal pads on both the MOSFETs and chokes, ensuring efficient thermal transfer where it matters the most. There's also a heavy plated heatsink over the upper VRMs, which combined with the integrated heat pipe helps distribute heat more evenly across the entire array. During my testing, even under sustained CPU loads, the VRM temperatures remained well under control without additional airflow. You'll see those results later on in the video. For DIY builders pushing high-end Ryzen chips to their limits, this level of cooling performance offers a peace of mind and demonstrates that MSI didn't really cut corners here. You'll also find this motherboard equipped with dual 8-pin EPS connectors. Totally overkill, especially for a 9800 X3D, but it's a bonus nonetheless. Furthermore, the connectors are all designed with solid pins. The solid pin design allows for a more stable transmission of 12-volt power to the CPU, even when handling high current loads. Unfortunately, I wasn't happy that MSI didn't relocate the connectors like they did with the 800 series boards for Intel. The Z890 Edge TI Wi-Fi I reviewed recently on the channel had it in an area where you'd easily be able to access it even when you're working inside a crammed case. Moving to the memory subsystem, the X870 Tomahawk supports DDR5 memory speeds of up to 8400 megatransfers plus, which isn't as high as what you'd see from their Intel 800 series boards, but that's more of a limitation on AMD's memory controller rather than the board itself. The board has 4 DIMMs slots capable of accommodating up to 256 gigabytes of RAM. This makes it an excellent choice not only for gaming, but also for creators and professionals needing high memory capacity and speed. MSI's Memory Boost and SMT technology ensures clean signals for stable overclocking. With this, they utilize a isolated circuit, so it's a direct path to the DIMM slots to further enhance signal integrity. Now, when it comes to memory speeds, your mileage will vary on this. Memory overclocking is dependent on a lot of things like the quality of your CPU's IMC, the kit you're using, and the layout of the board. Obviously, with this being a 4-DIMM board, it's not going to be able to push super high frequencies like a 2-DIMM board would. I will be expanding on my memory overclocking and tuning findings later on. This motherboard also is using an 8-layer PCB with 2-ounce thickened copper, which I would say has definitely helped in memory performance. Around the memory DIMM slots, you'll find a CPU fan header, a pump fan header, and 3 system fan headers. This motherboard has 8 fan headers in total, so there's plenty of cooling fans you can connect to it as well as pumps. We've also got an LED debug display, which apparently for this segment is a rare add-on, so I guess it's really nice to see here. And these are always handy to have because they display a code which the user can reference from the manual and find out what's wrong with their system if it's not posting. Along with that, it can double up as a CPU temperature display, so that's really convenient. Then we have the ATX 24-pin power connector, which also utilizes the solid pin connectors to enhance power transmission. Right below that, we have the ARGB easy connector header for your RGB lighting and fans, and I really like how MSI has unified all the different connectors to just one adapter. Then we have a front panel USB-C header, which supports data transfer speeds of up to 20 gigabits per second and 27-watt USB power delivery for fast charging. Then we have 4 SATA 6 gig ports and 2 USB 3.0 front panel headers, which is interesting as you usually just see one, but I do like how they're oriented, making cable management very easy when they're facing off to the side like that. Then at the bottom of the board, you'll find a plethora of headers, including fan headers, RGB headers, USB 2.0, HD audio, clear CMOS, and more. What's also new for this generation is that MSI have included a PCIe power connector at the bottom. You'll also find this connector present on their Intel 800 series boards as well. Think of it as an extra battery pack for your motherboard, an innovative feature designed to enhance system stability and performance during demanding workloads. By providing an additional 8-pin power connector, it supports up to 252 watts of extra power delivery alongside the standard 24-pin connector, ensuring reliable operation for high-power GPUs, intensive gaming, or resource-heavy AI applications. Usually the motherboard's 24-pin 12-volt power connector can only supply a maximum of 168 watts. While this might be enough for basic operations or basic builds, it falls short when you're trying to drive everything to its peak, especially these days when folks have a plethora of RGB fans, lighting strips, mini OLED displays on the AIO, and you have to run that with maybe a power-hungry GPU like an RTX 4090. The 24-pin and 8-pin power connectors deliver a combined total of 420 watts, giving the entire system plenty of power headroom to operate smoothly, even under the most demanding conditions. For onboard audio, we got the ALC 4080, which I've used on plenty of other motherboards. It's a fine chip, it'll definitely do the job for most users, and I haven't had any major experience breaking issues with it. It supports 7.1 channel surround sound and has SPDIF output. The MAG X870 Tomahawk Wi-Fi features an impressive and versatile area I/O layout designed to meet modern connectivity demands. For blazing fast data transfers, it includes 2 USB 40 gigabit per second ports and 3 USB 10 gig ports, 2 Type A and 1 Type C. Complementing these are 3 USB 5 gigabit Type A ports and 4 USB 2.0 Type A ports, ensuring compatibility with a wide range of peripherals. Honestly, if it were up to me though, I'd much rather see them split one of those 40 gig ports to 2 USB 20 gig ports or 4 10 gig ports, just allows for more connectivity. I think most users would rather have that as opposed to 2 dual 40 gig ports, but I don't know, then again you can just buy an adapter. Network connectivity is equally robust with a Realtek 5 gigabit LAN port for low latency wired performance and Wi-Fi 7 with Bluetooth 5.4 for cutting-edge wireless speeds, a dedicated clear CMOS button and flash BIOS button, simplifying troubleshooting and BIOS updates. For display needs, the motherboard supports HDMI 2.1, delivering up to 8K 60Hz, and then we have your audio jacks. The X870 Tomahawk Wi-Fi offers a robust selection of expansion slots to accommodate various build requirements. It features a PCIe 5.0 X16 slot, reinforced with MSI steel armor for enhanced durability and designed to support the latest high-performance GPUs. And finally, they've incorporated an easy release mechanism for the graphics card. They literally call it an easy PCIe release. But with a push of a button that's very accessible, it unlocks the slot so you don't have to dig your fingers underneath the card or underneath a tower cooler. The only critique I have of this is I wish they made the little lock a little bit bigger so you can easily see which position it's in. Additionally, we have two more PCIe X16 slots, with one running in 3.0 X1 mode and the other one running in 4.0 X4 mode, providing versatility for add-in cards such as storage controllers, capture cards, or network expansion cards. Since we're on the topic of expansion, that brings us to these shield frozer plates, two of which are toolless using their easy release mechanism, while there's another plate which requires the removal of 4 screws. Removing those will reveal 4 M.2 slots. The first one nearest to the CPU socket is the Gen 4 X4 M.2 slot, supporting speeds of up to 128 gigabits per second, and then we have 2 Gen 4 X4 slots, and we have 1 Gen 4 X2 slot. And just like the PCIe Gen 5 slot, all the M.2s are toolless, one finger operation with their easy clip design. Again, it just makes your life so much easier rather than having to dig around and fiddle around with tiny screws that can get lost so easily. And trust me, I've been there before, it's not fun. If you wanted to get a further understanding of how all the expansion slots and I/O are connected, rather than me explain it to you, you'll be able to get a much better understanding of it from this visual block diagram from the manual, which shows exactly that. You can see what is directly connected to the CPU and what is connected directly to the PCH, which carries over communication to the CPU. Aside from that, on the back side of the board, you don't get a backplate, but in this price range, I don't think there's anyone else offering backplates either, so I'm not really going to zonk them for that. Let's move on to the BIOS, and if you saw my Z890 HTI review, or have used one of these newer 800 series boards, then you'll know that for this generation, MSI have revamped and overhauled the UEFI. I won't lie, but the first time I saw this, it did really throw me off, but after using it for a while and familiarizing myself with it, I gotta say it's definitely grown on me, and I think MSI have done a great job with the design, bringing the UEFI to a more modern standard, and everything is laid out where you'd expect to find it. When you first load into the BIOS, you'll find yourself in the easy mode section where you'll find common settings and information that your average user would interact with, such as enabling the XPO or XMP profile, and they also have the one-click overclock options available for the CPU and NPU. Then pressing F7 gets us into the advanced menu, where you're going to find a plethora of options and submenus to really get into the nitty-gritty of system tweaking. On the left-hand side, you'll find tabs or submenus pertaining to advanced settings, overclocking tweaker, security, boot, and save functions. In the advanced menu, you'll find settings pertaining to stuff like iGPU settings, PCI Express settings, USB configuration, and more. So this gives you further control over your expansion devices and peripherals. In the overclocking menu, this is where you're going to find settings pertaining to tuning your CPU, RAM, and voltages. In the advanced CPU configuration, you'll find options such as Precision Boost Overdrive, which is AMD's auto overclocking tool with features like Curve Optimizer. I've used PBO on my 5900X when I was rocking it for my personal rig, and it did a great job being able to squeeze a little bit of extra performance from the CPU, so I look forward to utilizing it when tuning my 9800X3D. You'll also find settings to overclock and tune your memory. Now, one important feature I want to highlight that you absolutely must turn on is Latency Killer, especially if you're using an X3D CPU. For some reason, since the last Agiza update, memory latency is much higher than where it should be, but this option was recently added to mitigate it. We'll talk about that more in a moment. Amongst these settings, you'll also be able to further tune your memory and adjust fabric speeds. In the same overclocking menu, you'll also find where you can adjust all your voltages pertaining to the CPU, the SoC, and memory. So you'll notice a lot of options that you'd see in their previous generation motherboards are all still here. They're just reskinned a bit differently, but this should become really familiar to you if you've used an MSI motherboard in the last few years. I also really like how they include a hardware monitoring menu within the BIOS that allows you to adjust fan speeds from within rather than have to download another software within Windows. So you can easily set your fan curves and profiles here, and you can just forget about it. With that said, MSI do have their Dragon Center that you can download if you like to adjust settings within the OS, as well as be able to change your RGB settings. So overall, I really like this BIOS. I think MSI took a step in the right direction by taking their UEFI that I guess started to look a bit dated and then modernized it, but still kept everything in a very fluent and congruent manner where you can easily find all the settings in places where they make sense and you're not having to juggle through 5 different menus. But let's circle back to memory, and I wanted to talk a bit about my overclocking experience. Now, tuning memory on AMD versus Intel is quite different because of the way Ryzen's memory controller works. On Intel, you can scale well in terms of memory bandwidth and latency the faster you're able to push your frequency and lower timings. With Ryzen, not so much, because on a 1-to-1 ratio, you're basically capped at 6400 megatransfers, and that's with a golden sample. Most users are stuck at around 6000 or 6200, but you can run 1-to-2, although I don't see the point in running with that because it doesn't really improve bandwidth by a whole lot. It just doesn't scale like how Intel does, nor does it help reduce memory latency by a substantial amount. I feel like it was just implemented there to appease the XOC nerds. So what I ended up doing was just settling for a moderate overclock at 6200 megatransfers CL28 with tuned subtimings. This still gives me a nice bump over the stock XMP profile when it comes to bandwidth, and it gives me much better latency. Nothing extreme because at the end of the day, I'm using an X3D CPU, so I didn't see much of a point. Now, out of the box, just enabling XMP, I was seeing north of 80 nanoseconds. Yeah, 80 nanoseconds. Even with manual tuning, the lowest I could do was like 68 or 69, which definitely seemed off to me. And that's where the latency killer option comes into play. By enabling that, we're able to attain around 62 nanoseconds, and that is a dramatic improvement and brings it more in line with where we'd expect the latency to fall with those timings. So definitely enable this option. Even if you're not fine-tuning your RAM timings, it can be used in tandem with just your standard Expo and XMP profile. Furthermore, if you are lazy, MSI has implemented memory extension modes, which can further tighten the timings for you, and there's different levels, but remember, you're still going to have to stress test to ensure the configuration is stable. And they also have some triad profiles, which have tighter profiles than your typical Expo profiles that's loaded onto the stick. Overall, memory overclocking and tuning on the MSI X870 Tomahawk was fairly easy. The one thing I will tell you guys to be mindful of was the long training times. But after it's done training and you've dialed in a proper configuration that you know is stable, then the boot times are totally adequate and tolerable. Alright, so moving on to testing thermals, I decided to test with a half-hour stress test of Cinebench R23 just to get an idea of what we'd be looking at for VRMs, PCH, and the system sensor. Ambient room temperature was about 21 degrees Celsius. I ran the test 2 different times. The first test just involves the board itself with no airflow, and my 9800 X3D is cooled by the MSI E360 AIO, so this is the same AIO I've been using for my 14900K and the 285K. But it's exhausting air away from the open test bench. So while this test run shows you how the board handles cooling itself, I guess passively, it's actually somewhat unrealistic because in an actual case or chassis, there will be airflow over those components as you have fans installed in your case. At least I hope you would. So for the second run, I had a 140mm fan running at 800 RPM on top of the test bench, which I typically use to cool RAM with, but this will also function as an active cooler for the board. I'm also testing with PBO disabled for now, but we'll be coming back to that in the next CPU benchmark video. When we look at the results for our test with no airflow, the VRMs did a decent job. We're looking into the mid 50s or low 60 degrees Celsius range. Even with the peaks, it's nowhere close to where that would be a concern. The system sensor and chipset were also doing okay around 50 degrees Celsius with spikes into the mid 50s. Remember, this is during a very heavy workload for an extended duration, which I take it most users buying this board aren't likely to run into unless you're delving into some heavy production workload. Now, for our CPU, and this really isn't the main focus since we're more concerned about the board itself, but man, the 9800 X3D is one toasty CPU. It's kind of comical because people are always poking fun at the 14900K for running hot, but this thing actually runs hotter despite the lower power draw. And remember, this is with PBO manually disabled in the BIOS, so we're not even auto overclocking or anything, we're basically stock. Anyways, moving on, and when you bring in a more realistic scenario where there's airflow, as that's how your case will be operating, overclocking, the temps are significantly better. Not that they were anything concerning to begin with, however you can see here how the VRMs are now ranging from the low 40s to the low 50s, and that's also helped in lowering the CPU temps. Remember, as these components run hotter, they become more leakier, so the cooler they run, the more optimal the power delivery is. The motherboard system sensor and chipset also report much cooler temps as well. So yeah, overall with some airflow, this motherboard's cooling is absolutely adequate. You'll have the headroom should you need to push them, and when you delve into some heavy overclocking. To wrap things up, the MSI MAG X870 Tomahawk Wi-Fi is a solid all-rounder that caters perfectly to gamers and enthusiasts looking to pair a high-end Ryzen CPU with a reliable and feature-packed motherboard. Its robust power delivery, efficient cooling, and thoughtful design choices make it a standout in the mid-range category. While it doesn't aim to dazzle with RGB or flashy extras, it nails the fundamentals with great connectivity, excellent memory support, and versatile expandability. For its price, you're getting a motherboard that prioritizes performance, stability, and value, ensuring your build is ready for demanding workloads or marathon gaming sessions. If you're after a no-nonsense board that delivers where it matters the most, the X870 Tomahawk Wi-Fi is a great contender. If you're interested in picking this one up, I'll have an affiliate link in the video description. That'll do it for this one, you guys. We'll be touching base in the next video.
If you guys found this video to be informative and entertaining, then leave a like. Let me know your thoughts and comments down below. Be sure to check out the video description for cool links and ways to support the channel, such as using my Amazon affiliate link. And if you're interested in seeing more content like this, then consider subscribing. I'd greatly appreciate it. Thank you guys so much for watching, take care, and I'll see you in the next one.